Hello and welcome to CS225. My name is Jason Zych and I will be the instructor for this course. My status in the CS department is I'm our first permanent lecturer. I was undergrad in this department taking the same course you're taking now. I was in spring 92, I took this course, started in fall 91, graduated in May 95. I was a grad student for 3 years after that and got a non-thesis master's degree and teaching award as well, and so the department enjoyed or thought I was doing a decent job as a teaching assistant and kept me on as a part-time lecturer and then a full-time lecturer. And so my status now in the department is I've been hired as our permanent full-time lecturer. I teach 125 and 225 and do a few other things as well. So this is the first time this course has been offered, and I'm interested in the opportunity, and hopefully your comments that you may make as far as lecture and such will help me perhaps improve this for the next time as well if there are any problems, though hopefully there won't be. The TA for the course, there's sort of two TAs here. The first one's going to be Adam Loud, who is going to be giving your discussion sections. This is the first time the department's attempting to put two different lectures for the same course onto the web. Most 300 level courses have only the main lecture. This course has my lecture as well as, here at U of I, a 2-hour discussion section that would meet once each week with a TA. So we're going to be videotaping one of those for you each week as well. Adam Loud is going to run a special lecture similar to the way I'm doing for you, just specifically for the videotape people. We may have some students sit in from time to time, either in my lectures or in his discussion sections, to perhaps ask a few questions as well, if they're interested in stopping by to ask some questions. So you may see a little bit of student interaction here. The main reason we're not taping actual classes like the 300 level courses do is because both Adam and I make extensive use of the whiteboard, and the whiteboard doesn't translate well over video. So as a result, instead what we're going to do is we have the Elmo projector up here, and when appropriate we will, usually for my lectures that's all you'll see. You won't see much of me past this first lecture. But for the lectures that we're giving, we'll have a camera centered on the code that we're writing here and the pictures we're drawing, and you'll be able to see those both on the slides next to you as well as the live video feed, or not live, but the video feed of what I'm writing or what Adam's writing as we talk. And so that way we get around the whiteboard issue without having to alter the teaching style for our own section or lecture. And so we both decided we'd rather tape separately, specifically for the video, for the remote folks, rather than trying to make a hybrid lecture that doesn't serve either you or the local students as well as we would like. So that's why you won't have any students that you see asking questions unless they happen to drop by. The other TA that you will probably be dealing with more in a question and answer format is Charles Zhang, who is a graduate assistant, and he's going to be the one processing our lectures, syncing them up, synchronizing them with some of the HTML slides that you may be seeing to your left or to your right next to the whatever video box you're watching me in, so I can sort of point that out to you as the slide pops up. At this point, this being the first time I've done this, am not completely versed in exactly how much interaction he will have with you, but I'm assuming here that he will have some significant amount of interaction with you over discussion forums or whatever. So he'll be the person that you will be dealing with as far as the TA goes pretty extensively. I will do the best I can to be very available as well for questions, and so I don't at this point want to dump it all on Charles. I want to be available to you as well, especially because at this point there's only 14 or 15 of you, so it's not too much of an extra load on my own time between my other two courses. If there were 500 of you taking this remotely, it might be a bit of a different story. So those are the two TAs involved. Adam's been teaching this course now. This will be the third semester. He's won TA awards here as well. So he's a really great TA, and if the tapes we're making this semester become the tapes we use for the next 5 semesters or whatever, I'm really happy to have his section be the ones that are taped. Charles is new to this, but he won't be taping stuff. He'll just be answering your questions. So hopefully he will be excited about the opportunity. I believe he is, and the three of us together will hopefully provide you with a interesting experience taking this course, being the first remote class taking the course here at U of I. The course itself is about data organization. In an earlier course, if you had some programming, you should have had some programming if you're taking this, you may have seen arrays or linked lists. Both of those are container classes or container structures. They're designed to hold a number of pieces of some other information, an array of integers, a linked list of characters or floating point numbers or whatever else. And those are two possible data structures, but there are many others we'll look at. Hash tables, priority queues, disjoint set structures, graphs, a number of different data structures, and they all have their different trade-offs as far as, certain situations, one structure might be good in terms of the conceptual model it provides. In a different situation, another structure might be a better conceptual model. Or certain data structures provide better use of memory at the expense of a larger search time, where this data structure might have a faster search time, but would use more memory and therefore not be as memory efficient. So those are just a few examples of the kind of things that we're concerned about here as far as the class goes. And so we're not just going to be learning the data structures in isolation and having you regurgitate information on the exam. Our goal is, among other things, to enable you to be able to recognize when you write software which data structure would be the most appropriate one in a given situation. And so as a result, a large degree of the course will focus on comparing one structure to the next, which means there will always going to be the idea of tying the new information back to the things you've learned the previous 3, 4, 5, 6 weeks to enable you to compare this structure to all the others you've learned so far. So we're going to be constantly bringing the old information back into play on the exams, in the discussions, and in lecture. And so certainly this will be a course where you need to know everything at all times, as opposed to the kind of course you can perhaps learn the first week of material and then forget it after that first week. Here, everything pertains to the whole course. So once you learn something week 1, make sure you understand it and make sure you get your ambiguities cleared up, because you're going to need to continue to know that structure for the rest of the semester. The topic of software design is another topic that we cover here, software design and software engineering, and that is going to be dealt with by way of describing a few software engineering concepts and a few software engineering ideas. Mainly Adam will be taking care of that in the section videos, but those concepts are the kind of things that serve to make quality software. And the industry, hopefully, as it continues to move, or as consumers start to demand higher quality software, and the industry moves from a model of computing being a revolutionary thing in a sense, and so everyone's concerned about being first to market with this product or that product. When the industry starts moving to a more of a focus on quality being the main measure as opposed to first to market, or for those sections of the software industry such as consulting and whatever, and people writing space shuttle software and such, where there already needs to be a huge focus on quality, where the issue isn't grabbing consumers' attention first, but rather the software needs to be on time and it needs to be right. Those are the situations where formal engineering practices must come into play. And we would, as theoretical computer scientists here, prefer that that would be how everyone designs software. We do recognize the reality of the consumer area, but if all you've ever dealt with is the consumer area of software, and you think, well, why does software have these quality issues or such? Believe me, we all hope as well that someday the consumer area will be brought more in line with perhaps some of the other areas of software development, and that the very high quality, defect-free software will really start to matter even more than it's starting to matter already these days. The techniques for achieving that have been proven many times by many companies and many research groups and so on are the kind of things we'll be talking about, or introducing at least, in Adam's sections with the personal software process ideas. Certainly our 327 course here is the main software engineering course, but we will be introducing here a few of the ideas you might see there. And so you at least get a glimpse of things here, and then if that excites you, then 327 would be one of the courses you might look at later on as far as software engineering goes. And then the third topic of the course, outside of the data structures and the software engineering ideas, is C++. We will be teaching C++ in this course, but we assume prior object-oriented programming knowledge. Specifically, this course is designed to be a sequel to our CS225 course, which is taught in Java. So we're assuming that people coming into this course have had Java programming before. Does that mean you need to know Java for this course? No. If you happen to know C++ already, you're in great shape. If you don't know Java or C++, and your experience is, say, with C, for example, then there will be a little object-oriented programming you'll need to brush up on. At this point in time, I'm not sure what the background of the various people registered for the course is, all of you. I'm going to make an effort to find that out. And if I notice that people don't necessarily have a solid object-oriented background, I will make an effort to provide some review sheets or links to other resources where you can familiarize yourself more with those ideas, or perhaps I can just tape a auxiliary lecture where I explain the basic concepts. But that would be sort of as an extra tool. The course does assume you've had some object-oriented programming to begin with. It assumes you've had a pretty heavy emphasis on recursion in your past studies. And so we will not necessarily be dwelling on what recursion is. We'll assume you're familiar with that. Basically, the kind of things that we teach in our 125 course. In our timetable here, we emphasize that that's a very important requirement as well. But like I said, not knowing the background all of you have, or what kind of things we might need to do to bring individuals up to speed, I will be making an effort to provide resources that we may not provide to the regular students in the class here, just to ensure that if you do want to review certain concepts, that you'll be able to do so, because I would like everyone to get the most out of this course they can, rather than scaring off people now. So the tests and such will assume knowledge, but I will attempt to provide review resources for those of you who might be a bit rusty on this or that. As far as the books go, the main source of the course material should be seen to be my class notes. If you have looked over the early notes already before viewing this, or if you look at them later after viewing this, you may note that my early notes especially, I've attempted to have them approach the level of textbook chapters. They're almost lecture transcripts in a way, though certainly the lecture notes start when I start going over course material. This whole introduction thing isn't on the first packet. But the notes are the primary source for the course, my lectures, and I attempt to make the notes as much of a transcript of the lectures as I can. The textbook for the course is Data Structures and Their Algorithms by Lewis and Denenberg. The book is required because it starts to really come into play in the later half of the course. Over the years, I've been developing these very, very detailed notes, but I have at least for every topic in the course the kind of bullet point summary you might see from ordinary lecture slides as I try to develop my own material for the course. And so in the areas, the later topics like graphs and priority queues, where the only notes I have are a quick sort of loose summary instead of a wide-ranging lecture transcript information, what I'm basically doing is teaching very similar to this book. And so for the later topics, the book becomes the primary source in the sense of that's where you can read detailed explanations. You, of course, have the lecture video as always as a source. But between the book and my bullet point summary notes, the book would probably be somewhat useful in terms of a comprehensive explanation, with the bullet point summary notes that I provide getting to the nitty-gritty detail, or the essential details of the topics. Early on, I'm teaching much differently than the book covers the list and stacks and queue topics, for example. But on the flip side, my notes for those topics are extremely detailed, and so you really don't need to have the worry about the book in that respect. So this is loosely required in the sense that for some topics you may find it useful. For the early topics, you probably won't find it of any use. And so take it for what it's worth. I think it's a great reference book to have on the shelf, but as I supplant the book material with my own material, gradually we're going to end up phasing the book out because I'll have a lot of stuff in my own notes. So right now the course material is sort of a hybrid of the notes itself and the later chapters of the textbook. So that's why that's required. It's a very loose requirement. The personal software process book is a very loose recommendation. So if you don't have access to this book, you don't really need it. On our CS225 webpage, we have a link to notes, and the listing of notes we have are my own lecture notes, the section notes of the TAs, that you'll be able to access all of them, not just Adam's videos, but the individual slide notes for all the TAs. Notes on a few other side topics as well, one of them being PSP notes. Those are the software engineering topics we'll be covering, and they're basically taken from this book. But the presentation of the book is such that we're preferring just to kind of hit the essential topics quickly. The book is designed more to be a textbook to use in like a 2 consecutive semester, 1 8-week course followed by another 8-week course, or so on, to really give a broad view of the usage of these things. We're mainly just trying to introduce the ideas to you and not go through the whole big course that the book is intended for. And so as a result, we've got our own sort of summary notes, and Adam's section will cover those essential ideas to introduce them to you, and they will be tested on. But if you want the source material where we first were exposed to these ideas and the sort of deeper explanations of why they're useful and statistics and such, this is the book to have. But if you're content with just the explanations we give and you don't need to see the statistics for yourself or the paper references for yourself, then our slide note should be okay for that purpose. So that's why that's only recommended. And then the other recommended book is the Sustrup C++ Programming Language 3rd edition. This is the C++ Bible. The author of this book is the person who wrote the designed the C++ language. This book is pretty much everything you'd ever want to know about C++ and the various syntax rules. It's recommended because the resources we provide you should be enough to make to understand the C++ stuff we'll go over in this class, that we'll make use of in this class. The book is there if you want a deeper reference to explore other issues we may not discuss. If you're going to do programming significantly in the future, you're going to want a C++ reference book anyway, and that's the one to buy if you're going to buy any one, in my opinion. So that's why that's available. I would suggest that you do pick that up, but you probably won't need it for this course, and it's certainly not designed to be a beginner's book. And so certainly you'll want to look at our C++ notes and understand portions of the language from that first. Once you're comfortable with the language and you want to read up more on interesting pieces of it, then that's the book for you at that point. But it's certainly not a beginner's tutorial by any means. That's why our notes are in place as well. So that's the issue as far as the books go, books and the class notes. As far as the expectations I have for you and you have for me, things are radically different in a class like this than they would be if we were going to if you were in front of me taking the class locally, because there's all sorts of issues that the video takes care of as far as expectations and things like that. Certainly, I do intend to do the best I can to teach you as well as I teach the local students here, treat you with the same degree of respect that they would get, which is a very high level of respect. If you have concerns, complaints about things are handled, you're more than welcome to share them with me. I will grade you only on the work you do in this course, not, oh, this person liked me and this person didn't. That would be hugely unprofessional of me to base your grade on anything other than your work in this course. So I always encourage students to share their ideas, their thoughts, criticisms as well with me if they have them. Fairness is also very important as far as the way I want to treat the students. And part of fairness is treating everyone equally. So that does mean that as far as due dates go, there may be a little bit looser handling of due dates and such as far as the remote students go. Having not been through this course, I'm unfamiliar with all the details involved. Having not been through running this course on the internet, I should say, I'm unfamiliar with the various protocols for dealing with the remote students and hand-in dates. I'm going to assume in what I'm about to say that you'll have the same due dates and due times as the other students. If I'm informed that that's a little bit different by the administration, then certainly things might change a bit. But assuming that you're held to the same due dates and such, for example, then when the due time rolls around, if the MPs due at 11:59 p.m. on Wednesday, and you write me at 12:30 a.m. and say, oh, I've taken an extra half hour and fixed my MP, can I hand it in? The answer would be no. Not because that extra half hour is such a big deal, but mainly because other students didn't get the opportunity, and now they may have lost points they could have earned if they had taken that extra half hour and fixed up some errors. It isn't fair to them to give you time I didn't give to them. So those kind of things are very important to me as far as holding everyone to an equal standard, though certainly there will be situations that crop up, even with the local students, illness, away for a week on an interview, those kind of things, that might affect on a case-by-case basis how we deal with particular students. And the same thing goes for you, though I have no idea what kind of problems might come up as far as dealing with this class remotely yet. Certainly there may be case-by-case situations I need to deal with some of you that would involve then exceptions to the rules I might need to make. We'd make our best professional judgment as to when those exceptions are called for, but the goal at all times is to be fair to you. What we, of course, need to return is as always, basic civility. I tell the same thing to my local students, basic civility to each other and to the instructors and such on the discussion boards, and certainly to keep up with the course materials, know when the exams are going to be. If as far as the discussion forums go, make sure that you follow along and you keep up with the discussion forums, whether we use a web board or Usenet, so that you are always aware of any late-breaking course information that needs to be gotten to you. And I, of course, understand that the realities of the remote situation may be such that I maybe can't demand the same kind of instant response from you that I might have from the students here, though I really don't demand instant response from them either. But certainly if I say, you know, for example, we've made a change to the requirement of the MP that's due in 7 or 8 days, be aware of this change, I expect that within a week everyone's going to take note of that change. Which is why it's to your benefit to read whatever forum we have at least once a day, or perhaps for the remote students it should be once every other day. I'm not sure yet how that's going to work. So I'll be learning a little bit as we go as well about this. But here we tell the students to read our discussion forum once a day and see the posts people have made, the questions we've answered, and our responses to them. And at this moment I would expect the same thing of you. If I find a reason to learn that that should really be once every other day for the remote students, then that's cool as well. We'll talk about that a little bit more as the semester goes on as well. And that's basically the policies for the course. A lot of the other things I may have addressed aren't necessarily relevant to the remote students. I believe you'll be telnetting into our Unix machines to make use of your Unix account for the CS class here. We do have a Unix tutorial available off the web page. If you click on the resources link and then go to tutorials, there is a Unix tutorial you can download. And if you're unfamiliar with Unix, then when you log on to your account remotely, you can then run that Unix tutorial and get a feel for how things will work with that aspect. Though actually, it may not be designed for telnet access. It's designed for being in front of the window. So I may need to rework that a bit now that I think about it for the remote students in particular. And I will do that so that you have your own version of that as well now that I think about it. Because telnetting gives you different levels of access than you might get from being at the workstation with respect to pulling up graphic applications. All you'll be able to do if you telnet in is just actually run command line stuff. You can't pull up Netscape on a machine and have it sent back to your window unless you are running some sort of an X server, which I imagine most of you don't even know what that is, let alone how to run one. So we will be cognizant of that as well. We're not going to be dealing with graphic applications, just command line stuff. So telnet should work just fine for our purposes. The class will be very difficult. It always is. But the comments I've always gotten from students are that they found the class difficult but very rewarding, and they felt it was worth their time. And to me, that's the highest compliment that can be paid. That's what I'm hoping to have you feel at the end of the semester. I don't look at it like, oh, they're just the students. I really do take a place of great importance on the opinions you have of the class when you're all through it. And I certainly hope by the end of the semester you feel, just like I hope the local students feel, that the course was worth your time and your investment in it. And so we'll see how you feel at the end of the semester. That said, what I'm now going to discuss is a brief introduction to C++ from a Java perspective. The class is assuming knowledge of Java, but you don't need to know Java. The issue is, as far as the class goes, if you are familiar with Java, it makes understanding some of the C++ concepts easier, because I can say, you've seen this in Java, now here's the C++ idea, here are the similarities and differences. So that's how the material is taught. I will try and elaborate a little bit, because I'm not sure at this point what the various backgrounds of people here are, but that is basically the presentation we use both in the notes and in my lectures, is the idea of tying things back to what the student coming into this class knows already. I'm going to be, adding a little bit of extra information here and there with a thought that maybe I should be doing that for the lectures for all of you. So we'll see how that goes as well. The first question is, why C++? Why would we bother with teaching C++ instead of using some other language, or sticking with Java, which the students coming in here would know? Outside of all the noble academic concerns, certainly if you're going to view it, and though you shouldn't view it this way, but if you're going to view the purpose of taking this course as only trying to get a better job or something, certainly what I tell my students is, what's nice is at the end of this course, they've taken 125 and 225, and they now have under their belt a second language out of the set of popular common languages, C++ and Java being the two big languages in wide use with new software right now. So after this course and the precursor to it, 125, the students know Java and C++, which I think is a good thing, as opposed to having both courses in Java or both in C++. But that's not the only reason you should be concerned with learning languages, though given that this is not a situation where you're enrolling full-time in the university, that may be something that's of vital concern to you, and certainly it's a reason to learn a language because it's useful. One thing that's very nice about C++ is it's very similar to Java in the, for lack of a better technical term at the moment, basic stuff. The things like conditionals, if statements, for loops, while loops. When Java was written, they took the C++ syntax directly, or the C syntax, which of course is also the C++ syntax, directly for those things. So we don't need to spend eons of time studying control flow and the way in which methods or functions are called. Those things are the same in C++ and in Java and in C. So whatever language background you have out of any of those three, learning those topics of the other two languages is very simple to do. And that's why it's nice to teach one of the languages and then build the second one off of it. If you know C or C++ or Java, the other two become easier to learn as well. From an academic standpoint, which is more what I'm concerned about as the instructor of the course, you can learn more about languages in general by seeing a second example, or a third example, or a fourth example. So if you're taking this course with the idea of eventually taking, for example, 348, which is our artificial intelligence course, you may well learn Lisp or Scheme in that course, or Java if they teach it in Java that semester and you haven't learned Java already. If you take CS225, you'll get exposure to, I believe right now, they teach the course in ML, which is an interesting language. And so the more languages you see, the more you start to see, just as we'll see with data structures, the different trade-offs, why one language is good in one aspect, but what its deficiencies are. This language maybe makes up for those deficiencies, but has disadvantages that the first language doesn't have. And if you only are exposed to one language, you don't get a good sense of what makes a good programming language or what issues are to think about. The more languages you see, the better idea you get of the different trade-offs that are made when a language is designed. And I think that's very useful information, especially if you plan to pursue a higher level CS degree. But even just as a programming student or a CS student in a lower course like this, that's useful insight to try and achieve and to try and have at this point. Any knowledge you gain is always useful. The essential trade-off here, and the one that matters to us, is that Java is easier, but in a sense less powerful in some aspects, whereas C++ has more power in those aspects, and we'll discuss a little bit of that. But also harder to learn, the syntax can be more complex, and more error-prone. So because it's more error-prone, that means it's easier to write bad code in C++. It's easier to write mistake-riddled code in C++. Java was designed to be a language in which a lot of the common errors in C++ are not made when you write Java code. That wasn't its primary reason for being, but that was one thing people kept in mind, was that a simple language could potentially result in the programmer having a faster development time because a lot of the errors they might make in C++ they wouldn't make in Java. On the other hand, C++ allows you a lower level access to the machine. It provides for many different opportunities for optimization that Java wouldn't provide necessarily. It also has a few interesting features that the designers of Java chose not to include in the language. We'll talk about those as we reach them. And so there are things you can do in C++ that you can't necessarily do in Java. But power always comes with a price, and so the price is, a more complex and more error-prone language. So each language has its usefulness. There are times when there's no reason to use C++. Java would be faster development, and you wouldn't need the features that Java doesn't have. There are also other times when there may be features in Java C++ doesn't have, you want to take advantage of. There may be times when you really need to use features in C++ that Java doesn't have. And so as with anything, it's a matter of picking the right language for the right task. Just as in anything else, you have to pick the right tool for the right job. So there is no perfect programming language, just good languages for different tasks. C++ is compatible. Probably called that. Compatible with C, which was the precursor to C++. C++ was designed so that C code would still compile in the C++ compiler, and so a lot of old legacy system software can still run in C++ compilers, which was very important for the design of the language. And the other big topic for us is going to be templates, which are a feature of C++ we will talk about in detail later on. Templates allow us the ability to write data structures that are written generically. You don't write an array of integers or an array of characters or an array of floating point numbers. You have an array of some E type or some type T. And you don't really worry about what the type is. You just say, assuming I had a type T in each of these array cells, I could print this type out. I could do various operations with it. And then when you toss that code aside, when you want to use this code, you pull it up and that's when you fill in the type. And you say, oh, at this particular point, I want to make this an array of integers. You may make a second array using the same code, but say, this one's going to be an array of characters. And this third one will be an array of floating point numbers. And it enables you to write the structure generically and then fill in the type it holds later on, rather than having to write a separate integer array, floating point array, and so on. And so we'll look at that in far more detail later on, but that is a very useful feature, especially in a course that teaches container classes, data structures. And so that's going to be of very, very good use to us. And templates are more or less sort of the bread and butter of the course as far as a C++ language feature goes. So those are some of the reasons that we have for dealing with C++ in this course, just so you have a bit of exposure to why we might bother if you wanted justification for it, or more justification than just because we said so. In terms of points of first introduction, which I think it's useful to give you a roadmap of where we're headed. Features that are the same or almost the same. I've already mentioned things like control flow, features such as variable declarations and the various operations that you might use on those variables, addition, subtraction, blah, blah, blah. The notion of the main method, a few others. Any sort of quick review of those would tend to happen in section, if even any attention is brought to them at all. Those are the situations that between C and C++ and Java are identical or so nearly identical as to not really merit much discussion about them. So a lot of those things we just accept. Okay, look at the code, you'll see it's the same as you're used to from a Java or C background. Under the heading of same idea, different syntax would be firstly things like input-output. The way in which we read in data in C++ is different than both Java and C. Though certainly we can still use the C methods in C++, you really shouldn't, in my opinion. We have much nicer input-output methods that we can make use of, and we're going to look at those. If you come from a Java background, we have the idea here of global variables and functions. These variables and functions aren't going to work in a significantly different manner than those of Java, but unlike in Java, it is possible to have variables and functions that aren't part of any class. They're just standalone by themselves. And we will take a look at those kind of things as well. External file usage is another matter that's relevant. The idea of saying, well, if I have some code in this file, a function call, for example, a function I'd like to use, how do I use it in this other file? I've got some two-dimensional arrays written in this file, and I have a matrix multiplication function in this file. How do I use this function to multiply these two arrays together when they're in separate files? And the ways in which that's handled in C and C++ are very similar. The way in which it's handled in Java and C++ are a little bit different. So it's a similar idea, but it's worth exploring a little bit of the syntax involved with that. Some of that will be introduced first in section, and therefore only in section. Some of it we will talk about here. So that's another issue to concern ourselves with. And then the, I'll do things here, as far as new concepts, things like inheritance, which if you have the kind of background we would normally expect from students taking the course locally, inheritance would not be a new topic, but the syntax in C++ versus the syntax in Java is different enough that I more or less consider it a brand new topic. The ideas are the same. I will, with this class, attempt to perhaps elaborate a bit more on the ideas than I maybe would in the regular lecture, simply because some of you may have not had the inheritance background that the people who take 125 here might have. But the syntax is very, very different, and so I more or less consider it a new topic, even if you are very familiar with inheritance in Java. The idea of pointers in memory, if you have a C background, this won't be too different from what you're used to. If you have a Java background dealing with explicit memory management, dealing with explicit memory management will be something new. Templates, of course, are another relevant feature. A few other things as well, like operator overloading. And some related issues. Those will be discussed first in lecture. Section will reinforce those topics, but my goal here over the next 6 lectures or so will be to introduce those ideas to you, the tough ideas of learning C++. And some of the easier ideas I'll leave section to introduce because they're not too difficult and we don't necessarily need to spend lecture time on them. So that's where we're headed as far as the C++ roadmap goes over the next 6 lectures. In the remaining little bit of time, and I have at this point no idea if I've run over time or whatever, but I think I've probably run over time a bit, I will generally not be trying to run over time, though certainly I've been informed, and I think it makes sense, that the remote students would prefer to see topic-by-topic lectures. So for example, in lectures 2 and 3 here at U of I will typically have a pointer in memory lecture that I leave off at the end of lecture 2, finish in lecture 3, and then have a new topic for the remainder of lecture 3. Here I'm just going to tape lecture 2, the full 120 minutes or whatever, and you can watch various portions as you see fit, rather than me physically breaking up into the more of it and then the last little tail of it. That doesn't make any sense. But I will try and keep things down to the 50 minutes per lecture, though I think this first time I may be running late a bit. And this babbling I've just done hasn't helped matters. What we're going to do here in the last 10 minutes or so, 7 minutes, 10 minutes or so, is to quickly introduce how to convert a Java class to a C++ class. This will remind everyone, at least assuming you have the Java background, of how Java classes work. It'll introduce C++ classes in a way that ties in this new knowledge to existing knowledge if you have it. So again, if you have not had a Java background, what I'm about to write might not make much sense. That's not a problem. What is important is that you understand what I'm going to write at the end of this all, and that's what I'm concerned with. This is designed simply so that if you've got a Java background, you're drawing on that knowledge to try and understand what it is we're doing in C++. Here we have a Java class with 2 instance variables, both private, and then we're going to have 1 instance method. In the notes I have 2, but when I give the lecture, I only bother writing 1 up because the same ideas apply for both of them, and there's no point in me spending all my time writing code. We have here that the variable xcord of this class is set to x init, the parameter, and likewise ycord is set to y init. And so here, this is just a coordinate class. It holds 2 coordinates, x and y, and the initialize function will take 2 arguments, and it will assign the 2 member data to those 2 arguments. Now, in order to convert this to a class in C++, there are 3 things we need to do. The first thing we need to do is to at a semicolon at the end of the class close brace, i.e. right here. That's very, 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 very important. It's such a trivial little thing, but the way C++ is compiled, especially, or at least in our compiler that we use, but in general, I'm pretty sure, the way it happens to be compiled, the compilers generally have a huge difficulty figuring out what's going on when that's missing. Now, there may be some smart compilers out there that specifically now look for that problem and say, hey, you forgot your semicolon. But my experience has generally been that when you forget that semicolon, very bizarre things happen. The error messages that you get from the compiler don't at all relate to the fact that you're missing a semicolon. They more relate to the idea that the computer now has read past the closing brace there and is now trying to include other things within this class, and that never makes any sense. So don't forget that semicolon. And I'm belaboring the point because it's such a trivial little thing to forget, and yet, can cause the most confusing errors on earth if you don't put it there. The second point that we are concerned with is that we group access permissions, by which I mean, unlike in Java, we don't list private or public before every function and before every variable. Instead, in C++, we wouldn't bother putting that there at all, and we would instead write private up here after the open brace, but before the variable declarations with a semicolon. And here, whether we had one method or 5, we would not have public in front of every method. We would just start by saying void initialize, and up here, we would say public with a colon. And so the access permissions are grouped in C++ in a way in which we list one of these permission words, whether private or protected or public, and then after that word, everything until the next access permission word is whatever that term was. So everything between private and public is considered private. Once we have the word public, now everything after that is public until we hit another access permission word, and so on and so forth. So these are grouped in that sense. We don't need to list private or public after each one of them. And a lot of the complexity in C++ comes down to two different things. Sometimes it's because there's an extra feature in the language or extra power that Java may not have. Sometimes it's due to the fact that C code had to continue to be compilable in the C++ language specification. And so there are certain things that Java could perhaps do because it could start over, where C++, in terms of design, had to make sure that for example, if you left out private and public completely, as you would in C code, that should still make sense as C code. And so if you leave out private and public completely, everything defaults to private. But it is acceptable to leave those out, though usually you want to put it in at least for documentation, even if everything is going to be private. The other thing is we don't bother with access permission in front of the class name itself. So we would just say class cord in C++, and then have private and the variables, and have public and our member functions. And that then encapsulates things, public functions, private variables, as before, or as with object-oriented programming in general. So those are the first two things you need to do. The third thing you need to do is to separate the declaration and definition. And so I'm going to rewrite this code now in its final form. Those are the first two changes. The third change, most of this is what we've already done on the previous slide. We have here class cord, private, double, xcord, double ycord, and here we have public, and this is where it gets interesting. Void initialize, and here we will only list the parameters and the return type and the name, and then have a semicolon. That there is your file, meaning there is no implementation code. We put that somewhere else, and I'll discuss that too before we're done here. This is known as in C++, a header file. This is no different than in C, for those of you who are familiar with C. Typically, this is given a .h suffix, and so we often call it a .h file instead. If you come from a Java background, please note that in C++, unlike in Java, you don't need to have your file names exactly correspond to the class names. So for example, here I have a little c where the class is a capital C. If I wanted to call this mycord or even myfile.h, that would be acceptable as well. We don't need any linking between the file name and the class name, though it's usually helpful to have the file name bear some resemblance. But certainly if you had a long class name like linear hash table, if you wanted to name the file linhashtab.h, that's perfectly acceptable. So notice here all we have are variable declarations. This, which is known as a function declaration, or a function signature, all we have here is the return type, the name, and the parameters. The three things you need to know in order to use this function. You don't need to know how it's implemented to use it. If I say pass in two values, it'll initialize the member data to those two values. This is all you need to know. You don't need to know how the code is implemented. You just need to trust the comments, that the comments accurately describe what the code will do. So this is known as a function declaration or a function signature. And this entire thing then is a class declaration. Class declaration consists of variable declarations for the member variables and member function declarations and no implementation code. Sometimes you will have implementation code in here, but we'll discuss those circumstances and when it would be appropriate to do so. So the question is, well, what do we do with that code that we've gotten rid of? And the answer is we put that in an implementation file. The first thing we need to do is use what is known as a pound include statement, the number, the pound sign followed by the word include, and we will write here cord.h. This statement lets us know that the declarations inside cord.h are going to be needed in order to understand this code. And so when the compiler tries to compile the file we're about to write, it will look at those declarations for understanding some of the code we're about to write here. And then here we will write the original code we had before. Here's double x init and double y init. At this point, to where your left or right, wherever the HTML slides are showing up, at this point the whole code should appear, but you'll need to bear with me for a while I actually draw it myself. So we have here xcord equals x init, and ycord equals y init. I've left a hole there. I'm going to fill that in a second. This is the initialized code we had up earlier. And the only thing that's missing here is that we could have a number of classes all with an initialized declaration, a string class and a chord class and a clock class and whatever else, and they might all have initialized functions that take two doubles and return void. And so there's no way for us to know what particular class this initialized function is being tied into. We don't know if these are just, we're using variables before declaring them, or if their member data of the class initialized is supposed to be a part of. And so in order to make that unambiguous, what we do is we say, yes, this is the initialized function, but it's scoped to the class chord. When we had the declaration before of this function, we knew initialize belonged inside class chord because it was inside the open and closed braces of the class. So that was what told us that this initialized declaration was part of the chord declaration. Now in this situation where we want to know that we're now writing the implementation for the chord version of initialize, we explain that by basically having the class name that this function's a part of, followed by this, which is known as the scope resolution operator, or is sometimes called the binary scope resolution operator. The idea here is that's two colons, one after the other, and you place it between the name of the function that you're implementing and the class that this function is a part of. And so in a sense, this entire thing can be seen as the name of the function in a way. It's not just the initialize, it's the initialize function for the chord class, as opposed to the initialize function for any other class. And now we're done with this file, because now we've finished the one piece of the implementation we needed. We needed the implementation for the initialize function. This file now says include the declarations, and then here's the definition for the function that needs a definition. So this is one way to call this is the implementation file, or often called the .c file, because you would have a .C suffix for this. At least our code will. Other acceptable C++ suffixes would be .cc and .cpp. Those are two other things that tend to be file suffixes for C++ code. Just as .1c but a small c instead of a capital C would be C code, and .java would of course be Java code. And so we have cord.c here and cord.h in the other piece of paper, and those two together form this class. We have the class declaration. This is now the definition for the various functions that the class provides. And so when you want to use this class elsewhere, you include the core.h in that file, just as you did here, and the compiler will eventually link this file in. You never have to include .c's up here, nor should you, provided the compiler works the right way. So that there then is the introduction to C++ classes. You have your declaration and your definition for each class, your declaration file and your definition file. That's a little bit different than Java for those of you who come from Java. Those of you who come from C, this will be old hat, but the idea of a class itself will be a little bit different. And so you may not know what a class is, but the idea of separating definition and declaration, which infuses C and C++, shouldn't be anything new. And with that, we're done. Hopefully I didn't run too much overboard, though I probably did. We'll find out in a minute. What we'll start talking about in the next lecture, and that will again take up pretty much a 50-minute session plus a little bit more that we would then filter into lecture 3 with if you were here locally, is the topic of pointers in memory, memory allocation, and various other things relating to memory and pointers. And that's really, I think, the first really meaty, hard topic of the course. This, if you've got the Java background that this explanation was designed for, tends not to be terribly difficult, I think. Pointers in memory will be the really tough topic, and I will be attempting to explain it with some level of clarity. We will soon see. So I will see you in the next lecture, and welcome to the course.